Hello geometry students. In this video we are going to begin our unit on transformations, and in this video we'll be talking about reflections, translations, and rotations. Now all three of these transformations would be congruence transformations because they wouldn't change the shape or the size of a geometric figure. So let's start with the definition of a reflection in a line. So a reflection in a line is a function that maps a point, and in fact, why don't we go ahead and call that a pre-image point, a pre-image point. Let's add that in. So a reflection in a line is a function that maps a pre-image point to its image such that, number one, if the point is on the line, then the image and the pre-image are the same. So if you look at this example, here we have a point A that's on line K. K is called our line of reflection. So since the point is on the line, then the pre-image point is the same as the image point. So A would be our pre-image point. A prime, which is actually the same point, is the image point. So if the point is on the line, then the image and the pre-image are the same. Number two, if the point is not on the line, then that line of reflection is the perpendicular bisector of the segment joining the pre-image and the image. So if you look at this example here, here's our pre-image point A, here's our image point A prime, and you'll see that this line of reflection, line K, is the perpendicular bisector. I'm going to go ahead and add a little right angle symbol here. It is the perpendicular bisector of the line that connects the pre-image point A to the image point A prime. So let's practice sketching some reflections in the given lines. So we're actually going to start with example B because it's a little bit easier. So what we're going to do is use this definition of the reflection of a line to draw each image point. So let's start with point J. Now you'll see that point J is on the line, so that means J and J prime are the same point. Okay, now let's move on to K. So what we need is we need to draw or place the point such that line M is the perpendicular bisector of a line that connects K, the pre-image point, to K prime, its image point. So I'm just going to sketch a line, and what I'm trying to do is just freehand draw, and right about there is where K prime would be. Okay, and you can see that the line M is the perpendicular bisector, of the line that connects K to K prime. All right, so let's do the same thing with L. Let's kind of place L, and again, we're just doing this by freehand. Find where L prime would land, right about there. Okay, you can see that the line M is, again, it's the perpendicular bisector of this green line or line segment that connects L to L prime. Okay, so now if we connect the dots, J prime to K prime to L prime, and L prime back to J, okay, you can see, this isn't a perfect triangle, but you can see the reflection in the line M here. If you could fold your paper along line M, then of course point J wouldn't go anywhere, but L would land right on L prime and K would land right on K prime. Okay, so let's try the same thing again over here with example A. So I'm going to place A prime down right about here because line K should be the perpendicular bisector of a line segment that connects A to A prime. So again, we're just going to kind of freehand this, and right about there is where A prime would be. Okay, and you can see again that line K is the perpendicular bisector of this segment that connects, this segment that connects A to A prime, and then B prime would be right about here. Okay, and oops, that's supposed to be B prime. Okay, so again, the line of reflection, line K, is the perpendicular bisector of a segment that connects B to B prime. And then finally, let's place where C prime should go. So right about there. Okay, there's C prime. Okay, and line K is the perpendicular bisector of the segment that connects C to C prime. So then if we draw our triangle, A prime, B prime, C prime, you should be able to see that line K is a line of reflection. In other words, if you were to fold your paper along line K, A would land on A prime, B would land on B prime, and C would land on C prime. Okay, let's do one more example. And this one's kind of interesting because the line of reflection goes through the shape. So this line of reflection N, when we go to reflect, P prime is going to end up on the right side of the line, and Q, R, and S will all end up over here on the left side. So let's take it point by point, and we're going to start with point P. So I need line N, the red line, to be the perpendicular bisector of the segment that connects P to P prime, okay? And then the same thing with Q. Line N should be the perpendicular bisector of the segment that connects Q to Q prime. All right, and the red line N should be the perpendicular bisector. Oops, let me change color. The perpendicular bisector of the segment, right about there, that connects R to R prime. And then last but not least, let's find where S prime would land. So about there, S prime, okay? And then let's draw the quadrilateral, P prime, Q prime, R prime, S prime, and then back to P prime. So again, you can see how the shape kind of overlaps onto itself. But if you were to fold the paper along this red line of reflection, P would land on P prime, Q would land on Q prime, R on R prime, and S on S prime. Okay, so that's how we would, if you're asked to draw a reflection in a line freehand, that's how we would do it. But often we will be looking at reflections in the coordinate plane. Those are a little bit easier because we can actually graph something. So let's take a look at this next example. It says trapezoid RSTV has the following coordinates. So let's go ahead and graph RSTV. And then after we get it graphed, we're going to graph its reflection in the line y equals 1 and its reflection in the line x equals -1. So let's start by graphing our trapezoid. So I'm first going to graph the point R at 1, 1. So from the origin, I'll go to the right one and up 1. So R would be right there. Okay, and then next we're going to graph S. S is at 0, 4, so right here. Oh, I'm sorry, 0, we go left to the right, or we go to the left or right 0 units and then up 4. So S is 1, 2, 3, 4 right here. There's S. Okay, and then point T is at 4, 4. So from the origin, go to the right 4 and up 4. So T would be, let's see, 1, 2, 3, 4, 1, 2, 3. There's point T. And then finally, V is at the point 1, 2, 3, 1. All right, so draw your trapezoid. R, S, T, V, okay? And the first reflection we're going to do is we're going to reflect that trapezoid in the line y equals -1. So let's go ahead and sketch the line y equals -1. Remember, y equals -1 would be a horizontal line. So we're going to reflect this trapezoid in that line. By the way, you hear me say reflecting in a line, like you would look at your reflection in a mirror. Sometimes we might say, instead of reflecting in a line, you could also say that we're going to take this trapezoid and flip it over the line. So flipping over a line is the same thing as reflecting in a line. So let's first of all find where point R prime would be. All right, so if the red line is the line of reflection, then a segment that connects R to R prime should be bisected and perpendicular to this red dotted line. So that means that R prime should be, let's see, if R is 2.2 units above the red line, R prime should be 2 units below the red line, okay? And then the same thing with point V. Point V is 2 units above the line, so V prime should be 2 units below the red dotted line. So V prime would be right here. And then S is on the y-axis, and it is, let's see, 1, 2, 3, 4, 5 units above the red dotted line. So S prime would be 1, 2, 3, 4, 5 units below the red line. Let's see, 1, 2, 3, 4, right here, S prime. And then T prime would also be 5 units below the red line. So it would be right there. All right, and then sketch your trapezoid, and you can see the reflection in the line y equals -1. If you were to fold your paper along this red dotted line, this trapezoid would land right on top of this one. By the way, make sure when you draw these reflections, be sure to label your vertices. The pre-image points are STV. You don't put a prime on, but then the image points, you do put a prime on. Okay, so the next thing we're going to do is we are going to take this same trapezoid and we're going to reflect it in the line x equals -1. Well, that's a vertical line, so let me sketch that vertical line. It would look like this. All right, so that red dotted line should be the perpendicular bisector of any segment that connects a pre-image point to its image point. So let's start with S. S is 1 unit to the right of our vertical line, so S prime should be 1 unit to the left. So S prime would be right here. Be sure and label that. T prime, which is, let's see, T prime, which is 1, 2, 3, 4, 5 units to the left. So T prime should be, I'm sorry, let me say that again. T is 5 units to the right of our vertical line, so T prime would be 1, 2, 3, 4, 5 units to the left. Right here, there's T prime. And then we will plot R prime and V prime. I think you get the gist here of what we're doing. V prime, which is, let's see, V is 1, 2, 3, 4 units to the left, so V prime would, or to the right, so V prime would be 1, 2, 3, 4 units to the left. So V prime right here, and there we go. R prime, S prime, T prime, V prime. Okay, so again, these aren't great pictures. I should use a straight edge, but you should be able to see symmetry in those lines of reflection. So now let's do some common reflections that happen in the coordinate plane. And you might recall these reflections, doing these reflections in your Algebra 1 courses. But when we talk about reflecting in the x-axis, so for example, here's our point P, our pre-image point. If we reflect that in the x-axis or flip it over the x-axis, notice that its image point P prime has the same x value, but it's going to have an opposite y value. So in other words, when we reflect in the x-axis, any point xy would become the point x opposite of y. All right, and then if we reflect in the y-axis, so for example, if we take point P and we reflect it in the y-axis, notice that P and its image point P prime have the same y value, okay, because they line up horizontally, so they have the same y value, but they have opposite x values. So in other words, when we reflect in the y-axis, a point xy would become the point opposite x comma y. And then another interesting reflection is to reflect in the line y equals x. When you reflect in the line y equals x, notice that, again, that line y equals x is the perpendicular bisector of a segment that connects P to P prime, okay? And what happens is the point xy becomes the point yx. In other words, the domain value and the range value just switch places. You may have talked about inverse functions in Algebra 1. If not, I know you'll learn about those in Algebra 2. But when you talk about inverse functions, their graphs are always going to be reflections in the line y equals x, and the domain values and range values just switch places. In other words, xy, here let's go ahead and box this, xy becomes yx. So let's take a look at some examples of doing reflections in the coordinate plane. Okay, so in this first example, we're going to graph triangle ABC. Here are the coordinates of its vertices. Then we'll graph that triangle in the x-axis, which means we'll follow this rule for each point. And then we'll reflect it in the y-axis, which means we'll follow this rule. So let's first of all graph our triangle ABC. So A is at the point -3, 3. So from the origin, you'll go to the left 3 and up 3. So A would be 2, 3, 1, 2, 3. There's point A. All right, and then point B, its coordinates are 1, 2. So from the origin, we'll go to the right 1 and up 2. So point B is right here. And then point C has coordinates 2, 0. So from the origin, we'll go to the right 2 and then up or down 0. So C is right here. Okay. And let's draw, oops, let me try that again. See if I can get a straight line. Okay, triangle ABC. Oh dear. All right. Okay, so now let's go ahead and apply the rule for reflecting in the y-axis. In other words, we'll take the coordinates of a point. We'll keep the x value the same, but we'll change the y value to its opposite. So in other words, the point -3, 3 will become the point -3, -3. -3, -3. So let's go ahead and plot that point. And I'm going to change colors for this reflection. So 1, 2, 3, 1, 2, 3. There's where A prime would be. All right. And then point B, 1, 2 will become 1, -2. So 1, -2. And let's go ahead and plot that point to the right 1 and down 2. That is B prime. All right. And then C prime we will obtain by taking 2, 0. Now in this case, since 0 is its own opposite, xy becomes x, the opposite of y. So in other words, 2, 0 just stays 2, 0. All right, and then, oops, I'm going to do that in blue. And then let's plot that point, 2, 0, right here. So C and C prime are the same thing. All right, so when you sketch your triangle, you should be able to see the reflection in the in the x-axis. Okay, if you were to fold your paper along the x-axis, C would just stay where it is, B would land on B prime, and A would land on A prime. All right, so now let's take this same triangle ABC, and this time we're going to reflect it in the y-axis. So we'll follow this rule. XY becomes the opposite of XY. So in other words, -3, 3 will become +3, 3. Keep the y value the same, but take the opposite x value. So 3, 3, and then let's go ahead and graph that point. 3, 3, we'd go to the right, 1, 2, and up, 1, 2, 3. So there's A prime for our second reflection. All right, and then the point 1, 2 will become -1, 2. Right, -1, oops, -1, 2. Let's go ahead and plot that point. So to the left 1 and up 2. That is B prime for our second reflection. And then 2, 0 will become -2, 0. -2, 0. Okay, -2, 0. That is, so I'd go to the left 2 and then up or down 0. Let's draw that triangle. A prime, B prime, C prime. Okay, and so again, if you look at the blue triangle and the green triangle, you should see the reflection in the y-axis. All right, let's do one more reflection in the coordinate plane. This time we're going to take a quadrilateral JKLM and with vertices that are given right here, and this time we're going to graph its reflection in the line y equals x. So I'm going to start by just sketching that line y equals x faintly. Okay, and then we'll graph our quadrilateral and reflect it, and we should be able to see the reflection in that dotted line. So let's first graph our points. So J is at the point 2, 2. So there is J. All right, and then K is at 4, 1. So to the right, 1, 2, 3, 4, and up 1. Here's K. L is at 3, negative 3. So to the right, 1, 2, 3, and down 1, 2, 3. There's point L. And then finally, M is at 0, negative 4. Okay, there's point M. All right, so there's our quadrilateral. Now, to reflect this quadrilateral in the line y equals x, we will follow this rule. xy just becomes yx. So our first point, 2, 2, just stays the same, okay, because x and y happen to be the same. So 2, 2 will become 2, 2, all right. And notice that that point is on the line of reflection, so J and J prime are the same point, aren't they? All right, and then the point 4, 1, we're going to take that x and y and switch them. So 4, 1 will become 1, 4. Let's go ahead and plot that point. That would be K prime. All right, and then our next point, L, 3, negative 3, we'll take those x's and y's and switch them. So that will become negative 3, 3. So 1, 2, 3, 1, 2, 3. There's where L prime lands. And then finally, last but not least, 0, negative 4 becomes negative 4, 0. Negative 4, 0. So let's plot that point. That would be 4 units to the left of the origin. And the name of that point is M prime. So now, when we sketch our trapezoid, J prime, K prime, L prime, M prime, okay, you can see the reflection in the line y equals x. All right, so that will do it for reflections. Now we're going to talk about translations. The definition of a translation is as follows. A translation is a function that maps each point, each pre-image point, to its image along a translation vector, such that each segment joining a point to its image has the same distance, I could say distance, but I could also say length, has the same distance or length as the vector and is parallel to the vector. So remember, we've talked about this idea of a vector. A vector gives you two pieces of information. It gives you distance and it also gives you direction. So here we have a pre-image point A that we're going to translate, and what determines the translation is this vector K. So vector K tells us how far to slide point A, and it also tells us in what direction. If we take point A and we slide it along a path that's parallel to vector K and the same length as vector K, then we would end up here at point A prime. So let's do a couple of examples. We're just going to freehand draw some translations of the figure along a translation vector. So here we have triangle PQR, and this is the vector that determines the translation. So what I'm going to do is just highlight this vector, okay, and then each point is going to be translated the same distance and the same direction. So let's start with P, and again, this is not going to be perfect because it's going to be freehand. I need to draw a vector from P that is parallel to and the same length as our translation vector. So that looks pretty good. That's where my point P would land. Okay, and the name of it then would be P prime. All right, and then point Q, we're going to slide it the same distance in the same direction. Okay, hopefully this vector looks parallel to and the same length as our translation vector. So this is the point Q prime. Okay, and then we're going to do the same thing with point R. We're going to slide it, oops, I meant to do that in yellow, sorry. We're going to slide it the same distance in the same direction. So R would land right about here. Oops, sorry about that. Would land right about here. Okay, so again, this is going to be, oh, and the name of that point, excuse me, is not R, it's R prime. So if I had used a ruler and a straight edge, this would have been a little bit more accurate, but you can see how every point we have taken every point and we slid it, or we translated it the same distance in the same direction to get our image shape, P prime, Q prime, R prime. Let's try the same thing one more time. This time we're going to take this quadrilateral and we are going to translate it according to this vector. Okay, every point needs to be translated the same distance and the same direction. So point A, again, I'm just going to draw this by hand, but I'm trying to mimic that translation vector. So A prime would land right about here, okay? And then let's translate B. All right, so again, I'm going to try and mimic looks like about the right spot for B prime. Okay, and then point C, I'm going to change colors so we can see this a little better. C, we need to translate the same distance in the same direction. Okay, so use that there we go. So I tried to show how we're going to slide C the same distance in the same direction as that translation vector. And then finally, we'll do the same thing with D. We'll slide it the same distance and same direction. So right about here. Again, this isn't going to be perfect. So there's point D prime. Okay, and then when we draw the quadrilateral, it should appear that every point has been translated according to this translation vector. All right, so that's how you would do a translation freehand. When we're in class, I'll show you how to do this. We can use tracing paper to make this a little bit easier, but I think you get the idea from these examples. So now let's talk about translations in the coordinate plane. Translations in the coordinate plane are a little bit easier because to translate a point with coordinates x, y in the coordinate plane, we will just translate each point along a vector. Remember, this is what we call a vector in component form, where AB represents a horizontal change followed by a vertical change. All right, and so the rule that we'll follow to translate the point with coordinates the point P with coordinates x, y, if we're going to translate it along this vector, we would just add A to x and add y to b. All right, so for example, let's take a triangle EFG. Let's graph it, and then we're going to translate it along this vector. You'll notice these pointy grouping symbols. That means that this is a vector in component form. It tells us how far to move each point horizontally and how far to move each point vertically. So let's start by graphing our triangle EFG. So E is at the point -7, -1. 4, 5, 6, 7. So there's point E. All right. Point F is at the point -4, -4. So go to the left 4 and down 4. There's point F. And then finally G is at the point -3, -1. So 1, 2, 3, -1. So there's G. So let's draw our triangle EFG. And now we're going to translate this triangle according to this translation vector. So every point would get moved 2 units to the right, since it's a positive 2, and since this is a positive 5, it would be moved up 5. So to do it, let's go ahead and work it out analytically first, and then we'll actually count units and make sure that we've done it right. So our point E at -7, -1, we're going to increase -7 by 2. So -7 plus 2 would be -5. And then we're going to increase Y by 5. So -1 plus 5 would be 4. All right. And then this next point, I have a couple of errors on here. The coordinates of F, remember, were not -7, -1. Remember, the coordinates of F were -4, -4. So if you could make that change. And while we're at it, I don't know where this point H came from. Would you just please mark that out completely? That's not even supposed to be there. So sorry about that. Okay. So, oops, I'm missing a negative sign here. So let's take point F, whose coordinates are -4, -4. Let's increase the x value by 2 and the y value by 5. So -4 plus 2 is -2, and -4 plus 5 is +1. And then finally G, whose coordinates are -3, -1. When we increase -3 by 2, -3 plus 2 is -1. And then -1 plus 5 would be 4. So let's go ahead and plot those 3 points. So the point -5, +4, we'd go to the left 1, 2, 3, 4, 5, and up 1, 2, 3, 4. So there's our point E prime, okay? Point F prime is at -2, 1. So let's plot that point. -2, 1, there's F prime. And then G prime is at -1, 4. So we'll go to the left 1 and up 1, 2, 3, 4. There's G prime. Okay, now let's go ahead and draw the triangle, and let's just check each point. Let's see that each point has been moved. Let's start with E. Now, according to our translation vector, we should move 2 to the right and up 5. So from here, we're going to go 2 to the right and then up 1, 2, 3, 4, 5. So we can see we've plotted that one correctly. G is 2 to the right and up 1, 2, 3, 4, 5. And then finally F, 2 to the right and up 1, 2, 3, 4, 5. All right, so that's doing a translation in the coordinate plane. So next, we're going to talk about rotations. Our next transformation is a rotation, and here is its definition. So a rotation is a function that maps a point, in other words, a pre-image point, to its image by rotating the point about a fixed point called the center of rotation. The center of rotation. Rotation. Okay. Through an angle of x degrees such that the following 2 things are true. First of all, if the point is actually the same as the center of rotation, then the image and the pre-image point would actually be the same point. All right. But if the point is not the center of rotation, then the pre-image and image point are the same distance from the center of rotation, and x degrees is the angle formed by the pre-image, the center of rotation, and the image. So let's look at an example so all these words will make sense. So here we have a pre-image point A that's going to be rotated 120 degrees. So if we take point A and we rotate it 120 degrees about point C, which is our center of rotation, notice that A prime ends up over here, and this last part that says the distance from the center of rotation, let's see, this next part that says x degrees is the angle formed by the pre-image, the center of rotation, and the image. In other words, if I start my pre-image point, go to the center of rotation, and then to my image point, that makes a 120 degree angle. Okay? So one thing we need to make note of is that when we rotate, when we're doing translations that are rotations, rotations will always be in the counterclockwise direction, unless indicated otherwise, okay? So if it doesn't say what direction to rotate, we'll just automatically assume that we're rotating in the counterclockwise direction. So if you were to look at the face of a clock, an analog clock that has hands that sweep around, this is the direction that the hands go on a clock. That's called clockwise direction. So if we go in the opposite direction, that's what we call counterclockwise direction. So that's how we'll always rotate unless otherwise told otherwise. So we're going to start by doing a rotation that's not in the coordinate plane. So this will just be a freehand rotation. We're going to draw a 90-degree rotation of triangle ABC about point P. Okay, so we're going to take this triangle, we're going to rotate it about this point. Now to do it, we're going to do it point by point. Okay, so let's start with point A. We're going to take point A and we're going to rotate it 90 degrees. Now, since we weren't told what direction, we assume that's in the counterclockwise direction. So we're going to rotate A 90 degrees, okay? So, according to the definition, the distance from P to A and from P to A prime should be the same, and also the angle formed by A, P, and A prime should be a 90-degree angle. So now we're just going to do this freehand. So what I need to do is draw a segment from A to P, and then draw a second segment from P to where we think A prime ought to be, and notice that the distance from P to A should be congruent to the distance from P to A prime, and the angle formed as we go from A to the center of rotation to A prime, that should form a right angle. So I think we've done a pretty good job here. Those segments look congruent, and it looks like the angle formed by A to P to A prime forms a right angle. So now let's do the same thing with B. Okay, so I'm going to switch colors here. So I need to put B prime in a place where B prime is the same distance from P that B is, and that also B to P to B prime should form a right angle. So it looks like I need to go straight up, and that looks about right. So B prime ought to be right about here. Okay, so again, you can see that the distance from B to P and B prime to P are congruent, and the angle formed as I go from B to the center of rotation to B prime, that makes a right angle. All right, and so last but not least, let's rotate C. Okay, so C to P, and then I need to make a right angle here, and the distance from C to P should be congruent to the distance from C to P prime, or let's see, C to P should be congruent to P to C prime, excuse me. Okay, all right, and then let me go ahead and sketch that triangle, A prime, B prime, C prime. So that looks like we did it, well, it looks a little small. Looks like I could have put B a little bit taller. But what we'll do, and when we do this in class, is we'll use some tracing paper, and we'll be able to rotate with tracing paper, and you'll be able to see that a little bit more clearly. So using the definition and sketching a rotation freehand is a little bit tricky. So let's take a look at doing rotations in the coordinate plane. Those are a little bit easier because we have some rules to follow. So let's take a look at those rules. First of all, a 90-degree rotation, and by the way, these are all going to be rotations about the origin. So why don't you add that to the title? So these are rotations in the coordinate plane about the origin. Okay, so let's start with a 90-degree rotation. Now again, unless you're told otherwise, we're talking about a counterclockwise rotation. When we take a point and we rotate it 90 degrees about the origin to find out where the image point would be, all we need to do is follow this rule. XY becomes the opposite of YX. So we're going to take this point 5, 2. Where would P prime be? it would be if P has coordinates 5, 2, then P prime would be switch them and, well, change the sign on Y, then switch them. So 5, 2 would become negative 2, 5. So you can see that 90-degree rotation here. And you can see the distance from P to the origin and origin to P prime. Those segments are congruent. Okay, to do an 180-degree rotation, okay, XY just becomes, all we have to do is change the sign on X and change the sign on Y. So for example, if our pre-image point is point P with coordinates 5, 2, then after that 180-degree rotation, P prime would be at negative 5, negative 2. All we did was change the signs. And then the last one we're going to look at is a 270-degree rotation about the origin. So to rotate a point 270 degrees, just take its coordinates x, y, and you're going to change the sign on x and then switch them. So x, y becomes y negative x. So for example, the same point P, 5, 2, when we rotate it 270 degrees, would become 2, negative 5. So let's do one example of a rotation in the coordinate plane. So we're going to take triangle PQR that has these coordinates, and then we're going to graph its image after a 90-degree rotation about the origin. Okay, so here's the rule that we'll use. Let's start by plotting the 3 points. So we've got P at point 1, 1, and then we have Q at point 4, 5. So there's point Q, and then R is at the point 5, 1. There's point R. Okay, so let's, oops, I shouldn't have primes on those. I don't know what I was doing. Let me erase that. There should be no prime because those are our pre-image points. All right, so let's draw the triangle PQR. All right, and now let's rotate it 90 degrees about the origin, and to do that we'll just take each XY, we're going to change the sign on Y, and then they'll switch places. So 1, 1 will become negative 1, oops, sorry about that, will become negative 1, 1, okay. The point 4, 5 will become, okay, change the sign on Y, and then switch places, so that would be negative 5, 4, negative 5, 4, and then the point R at 5, 1 will become negative 1, 5. Negative 1, 5. So let's graph those points. So negative 1, 1 would be right here. That's our P prime. Point Q prime will be at negative 5, 4. 2, 3, 4, 5, 1, 2. So go to the left 5 and up 4. That's Q prime. And then R prime would be at negative 1, 5. So there's R prime. All right, so now let's draw that triangle. Okay, and then again, what we'll do in class is I'll show you how we can trace these shapes and rotate them, and you can, what we'll do is we'll hold a pencil at the center of rotation and rotate a piece of tracing paper, and you'll be able to see that. All right, so the homework will be placed in Google Classroom, so you can go ahead and get started on that. And if you have any questions, be sure and ask me in class.